For number 10, I can tell this is an exponential decay problem because of the value of b here. Since b is a number smaller than 1, I know that my values are going to be decreasing. So let's start with the starting point at 8, right here, and let's decrease it by a half every time. So half of 8 is 4. So as I move 1 to the right, I'm going to go down to 4. And half of 4 is 2. And half of 2 is 1. And half of 1 is a half and a quarter. And those numbers were pretty straightforward. So moving to the left, I'm going to double it instead because we're kind of going left to right here. So for 8, as I go to the left, I'd go up to 16. And then actually my graph doesn't even go up to 32. So I'm just going to kind of fill in where it's supposed to be. Now, once again, we're going to have an asymptote. And it's important to label your asymptote. So my asymptote in this case, once again, is at y equals 0. And it means that it's where my graph will approach but never reach. You could keep taking half of something. You could keep taking half of 8, half of 4, half of a quarter, whatever we're taking half of, and it would never become 0 and it would never become negative. And that's why we have an asymptote, because it shows, okay, no matter how tiny you get, you're never going to get smaller than 0 because we're not subtracting, we're halving. So in this case, our asymptote once again is y equals 0. We're talking about decay, and just keep an eye on that b and just see what number it is, and if your numerator is smaller, small, large, small over large, then you're going to be getting smaller left to right. And if it's the opposite way, as in the prior example, 2 is our number, which is really 2 over 1. So that's why it's growing, because the larger number is on the top of the fraction for our b.